And I'd like to welcome Carlos Vicente from Dyn Inc., who's given us a presentation before about automation, done a lot more work, and has a very thorough update to offer us. Thank you, Carlos.
Does this work? Yep. So, Carlos Vicente with Dyn, here to talk about network automation and experiences. Does this work? Yeah, the big green button. So what is Dyn? We're in the internet performance business. We have about 20 data centers, hundreds of network devices, and the key thing is we have very small teams, and so automation is a very important thing when that happens. You might or might not have heard of our project Kipper. We gave a presentation in NANOG 63. And it's our continuous integration approach to configuration management. By continuous integration, I mean distributed workflow with version control, automated tests, that kind of thing. You can see the presentation at NANOG 63 for more details. This is more of a follow-up to that. So, in brief, this is how the workflow goes as a reminder. So you have engineers that need to make changes. Each one of them has a copy of the repository with a lot of data and scripts and things. So that person makes a change, sends a pull request using GitHub. The pull request sends a notification to a thing called Jenkins, which is a little service that runs things for you. Jenkins can run, well, Jenkins has a copy of the same repository and runs Ansible for us. With Ansible, what happens is we do a dry run. So first of all, we render all the configurations using templates. So Ansible grabs all the data, all the information, all the variables and templates, and generates the final configurations and sends them to the network. But it doesn't commit them. It just does a commit check in Junos parlance. It comes back with the differences between what is supposed to be and what it is in reality. Those differences are very important because that's how we can evaluate whether the change is valid and exactly what's happening. So we send those differences, we put them in a gist with nice syntax coloring, and the link is sent to the chat channel, where an administrator, another network engineer, reviews the differences, and that person decides whether what the other engineer is doing makes sense, whether it passed the syntax checks, and hopefully approve it and merge it into the canonical repository, into the canonical branch. After the merge, GitHub sends another notification to Jenkins. Jenkins renders those configs again and commits them to the repository. So now we have the repository is updated with the configurations that are supposed to be in the network. Notice that they're still not in the network. They're still not pushed. And the final step is that someone, either the person who issued the pull request or the administrator that approved it, makes a decision of when to push that and how exactly to push that. And that person uses also Ansible, and it's all very easy with a makefile and just says make deploy, and things happen. So in a normal day, we are keeping an eye on the channel, and we get notifications like these. GitHub is saying someone, well, Steve in this case, sent a pull request, and he's adding some routes or whatever. Immediately, Jenkins says, okay, I got work to do. So Jenkins starts rendering the templates and doing the dry run that I talked about. After the dry run is done, the results are sent, again, as a link. It says, Kipper, dry run number 251, the results are available here for your review. So you go and check that. And it looks something like this, nice diff with red and green lines. And it continues on as I explained before. So we've been using it, and you know what? It actually works. This has been a good tool. We are using it to rebuild our sites, our edge sites, globally. We started halfway around the world, because that seemed to be a good idea. So we started with Hong Kong, we've done Singapore, we're going to be doing a lot more in the coming months. And yeah, we all use it in network engineering, but not only us, other groups are also using it. So the systems guys, when they need to make a change, they send us a pull request, and we are out of the business of turning up ports or changing ports configs, or all that comes directly from them, which is a big win. And in the meantime, we've learned a few things and made it better. But first, some stats. We have, as I said, about 300 devices in inventory, about 88 template files. Those are in Jinja 2. If you know Python, that will sound familiar. 900 lines of generated configuration. That sounds like a lot, but maybe it's a bit bloated because it's all XML. Almost 1,300 commits to the repo, about almost 5 commits per day from 17 authors. And an interesting fact when I was looking at the stats was that most commits happen on Thursdays around 4 p.m. I don't know why. So, some of the challenges. So, when we started using it, we started simple. And one of the things you do with Ansible is you group things. And the groups are essential for you to be able to use variables. And you apply those variables to different groups. And you avoid repeating things. It was evident that maintaining those groupings in one YAML file was not scalable, so we started looking into Ansible's dynamic inventory, and that's nothing more than the ability to pass a Python executable to the Ansible playbook tool. And that executable is responsible for loading all the data into data structures that then are passed as Python to Ansible. And of course, once you have an executable, you can do anything with it. You can read data from anywhere you want. And what we did was, okay, so let's just keep a very, very short, concise inventory of everything we have. And let's use our naming scheme to group things. So one thing is, for example, I group things by site, all the stuff in North Bergen or all the stuff in Tokyo, etc. I group things by function, all my edge routers or my spine switches, etc., etc. I also create intersections of these. So sometimes I want to push to or make a change to all the top of rack switches in Palo Alto. And then also groupings based on model. Is it a Juniper MX router, EX switch, et cetera, et cetera. So there's a lot of groups. It was also evident that there was too much data that needed to be kept in YAML files, which is the basic way to represent information or variables for Ansible. So the solution is to use that dynamic inventory script, not just for grouping things, but also to load variables. One very important case is we have a lot of point-to-point links, right? And all these point-to-point links, many of them are trunks, and they carry different VLANs, and each VLAN has a point-to-point subnet, both in v4 and v6. So the natural way to represent that was in tabular form. So we created this spreadsheet with all the devices in a data center, their ports, and the mapping of this port goes to this other port. This is a type of link, and these are the various pieces of information that pertain to that point-to-point link. One very cool thing was we didn't have to put the specific IP addresses for each side. One easy way to do that is to just put the subnet in there and use a convention that anything on the left uses the first address and anything on the right uses the second address. So the dynamic inventory script just calculates those variables and assigns the variable to the device appropriately, both for v4 and v6. And the spreadsheet, we don't read the spreadsheet directly. We convert it into CSV, and we put it in version control. I like to have things under version control. It's always better. But you say, well, that data is coming from everywhere, from somewhere. And as you heard this saying, garbage in, garbage out. If you input bad data, you get bad results. So things we had to do were, for example, adding checks for duplicate addresses, because we obviously were starting to copy-paste and started duplicating things, and that wasn't a good thing. So now, if you make a mistake, immediately the inventory script is going to tell you you have been repeating or duplicating IPs, and things of that nature. We put a lot of checks in there. Another thing here is that all our sites are now automatically subnetted. So we took a new design that we had, we made it work in the lab, we decided how we were going to partition the address space, and we took that model and we wrote some code that generated all the input that we had to put in spreadsheets and also to feed to our IP address management tool. And we did that once for 20 sites. And that guarantees that all the input information is going to be exactly the same, and we're not going to be partitioning each address space manually, because that obviously is going to end in very, very bad results. Another case was server provisioning. So we were, okay, step back. We use multi-chassis lag in our top-of-rack switches with our new servers. And when you're provisioning, of course, the server doesn't know that it's supposed to be running LACP, so you need to tell the switch that you need to force up the LACP status or state. And we were doing that temporarily on demand each time. And then the systems guys would finish provisioning, and someone would go in there and change that. And of course, first of all, it's manual. It's an interruption each time. And worst of all, we were forgetting to remove the force up after the server was provisioned, which is a very, very bad thing. So we said, well, let's let Kipper do this. So as part of the whole rollout, what we did was, let's assume that anything that is not used is a provisioning port. So everything is forced up by default, and everything has all the default settings, and you can provision something anytime, whenever you want. You don't have to bother me. And once you are finished provisioning the server, then you send me a pull request with whatever parameters you want for that port, and I'll happily merge it and push it. So that was a big win. So you change things. I'm positive this little change won't break anything. How many times have we said that? How could this possibly break anything? Well, it braked. It breaks. It broke, and then people say, you broke it, and you go, are you sure that was working before I changed things? Well, you have no idea, and you have to roll back, and then it turns out that, yes, it was your fault. We didn't have a good way to test connectivity, both before and after changes, and in our case, we have a lot of routing instances within one site, and then multiply that by 20 sites, and you have a lot of possible sources and destinations that you want to test. And so doing that manually was not scalable again. And Ansible came to the rescue. And because we use netconf, we can tell our switches to run things for us. So what we did was to use the same inventory data that we used to configure the devices to generate a list of tests that we wanted to run before and after changes. And then we also added a playbook for doing rollbacks. This is one example. So you type make ping test, and it runs a lot of pings from many different top of rack switches to many different destinations. And if everything comes out green, then you know you haven't broken anything. That's all done with a very simple module that comes for free. It's all on GitHub. It's called Junos Ping, and what you see here is a playbook. And the things in between curly brackets are data structures that come from the inventory script. Then there's an issue of change awareness. Sometimes we would forget to notify other groups that we were pushing a change. And for some reason, the NOC didn't like that. I don't know why, but it wasn't a good thing. So we modified the deploy job, and we now automatically send notifications via Slack to different groups. So now they know exactly when we are pushing things. When I gave the talk last time about what we were planning on doing, I mentioned that ideally we wanted to let the thing push changes automatically. So once you merge a change, you forget about it, and it's all magically done for you. Turns out that wasn't very realistic. I hadn't thought about it very deeply. So, if you've done this, you know that sometimes a change depends on another change. It's complicated, and you really want a human making some of these decisions. So we decided to not automate that part. And as I said earlier, there is a person that always decides when to push something and how to push it. What to do with legacy configs? It's very hard to adapt configurations that have been crafted by hand over years because there's so many inconsistencies. And more than anything, you waste a lot of time looking at something and going, is this really necessary? And so you have to go around asking others who have been in there longer than you if they happen to remember why that section was in there. So in short, it takes a long time to adapt a large network, a lot of configuration, and put it under version control and templates. So what we did was to focus on our new designs, our new sites, and what we're doing is automating everything from the beginning. So we rack things up, we plug things in, run Kipper, and things are magically working because we already automated all the config. The idea is then you go back and fix the old legacy network as time allows. But it might be that because you're so efficient at upgrading everything to the new design, the old might go away sooner than you think. So another cool thing we were doing is audits. So of course, we're automating everything, but that doesn't make it impossible for someone to make a change directly on the CLI. Sometimes that happens. If you don't keep an eye on that, you might find that when you're trying to push a change days later, that you notice that you're actually going to change more than you thought you were going to change. Why? Because what they changed is not in your templates. So we do a nightly dry run using Jenkins. So you just program it and say, at this hour, just do a dry run and send me the diffs. And so in the morning, you look at your Slack channel and you see if there were any changes that you need to pay attention to. It could go either way. Maybe the change needs to be overwritten because it was a temporary thing, or it's a valid change that needs to be incorporated into your templates and your variables. Another thing we changed, initially we were gathering facts using Ansible and netconf prior to rendering the templates. This was useful because there's a lot of decisions that you make while writing the template. For example, there are some versions of Junos that don't support something, so you're going to be checking, okay, is this more recent at 12.3, or if this is an SRX, I need to do it differently. But in reality, this was causing the dry run process to take very long, and most importantly, it didn't allow us to generate things before things were deployed. So if I wanted to generate the configs prior to going and upgrading a site, I couldn't do this. So we did away with that idea. And now what we do is we just encode the model and the version in the basic inventory file. And that, there's a bit more maintenance, but it hasn't been an issue. In many cases, the dry runs get interrupted, and that's painful because they take a long time sometimes. Mostly because we have a lot of CPU-challenged devices. That's what you get from buying cheap L3 switches. And so, as I said, it's painful when they get interrupted, and it happens for various reasons. The most common one is someone is at the CLI trying to change something. And so, because Kipper is trying to acquire an exclusive lock on the CLI, it can't. And so the whole thing breaks, and you have to run it again. And that's a pain. Of course, once you have finished automating all your configs and templating everything, the possibility of someone being at the CLI is going to be lower, right? When everybody gets on the boat and starts doing things the right way. But in the meantime, we just tell Jenkins to run again. Sometimes it fails for other reasons, and we try to fix those. Or in the worst cases, we have to comment out the device from the inventory and just deal with it later so that the rest can work. Git is, as you know, very powerful. If you've done any software development, it's fantastic, it's great, it allows you to do so many things, but at the same time, it's very complex. I myself keep Googling, how do I do this in Git? It's hard at first, and that's been a challenge with getting people up to speed in the engineering group. Most common thing is, oh, I didn't create a branch, so I can't interrupt what I was doing and work on something else. I committed a change that wasn't accepted, so now my master branch is wrong. I merged from the wrong branch, and now I have a mess. In general, I don't know what I did, and my Git is all messed up. Help me. So that's been a common issue, and it's just a matter of more training, more experience, and people are getting up to speed. We kind of have an inside joke at Dyn that all three-letter words are hard. So Git, DNS, BGP, everything is hard. The other thing is, but it worked for me. Because we all have Ansible and all the whole thing in our laptop, sometimes we run into issues because we might have a different version of the OS. We don't have the same version of the libraries, different version of Ansible. So I'm saying, well, everything works for me, but a colleague might say, well, this broke. And that's very annoying. One solution is to create a VM somewhere in the network and put all these tools and libraries, and everybody just logs into that VM and executes things from there. So with these tools, there isn't a lot of complex coding necessary because, Ansible is already has a lot of logic to help you there. But still, you need to be aware of some basic programming things. You need to understand a little bit of data structures. What's a list? What's a list of dictionaries? What's a dictionary of lists? And things like that. And so I recommend to everyone that they pick up the Python book and learn some of the basics of Ansible. And it's not hard. So I could say confidently that the major gain from all this stuff is consistency. In almost all cases where two or more things were supposed to be the same, they were not. always was something different that someone messed up. And Kipper has really, really helped us notice and correct these issues and not have these issues anymore. So that's been awesome. The future, we want to test beyond our own network. You saw that I talked about doing ping tests between subnets, in between sites, and et cetera. But what happens when I make a change in my routing policy? I want to see how that has been reflected from the point of view of others, and how our reachability looks across the internet. So gee, I think I know a company that does some of that. So yeah, we'll be looking at using some of Dyn's Internet Intelligence API features to integrate it with our own change management to make sure that we didn't break anything again. Conclusions. So yeah, network automation is not without its challenges. It's a process. It takes a long time. Some of the challenges are technical, some of them are organizational, getting people up to speed, changing mindsets, etc. But it is an investment that pays off significantly. I mean, I couldn't imagine doing what we're doing right now without these tools. So I highly recommend doing something like this if you're not already. And now we have some 6 minutes almost for questions. Yes?
Oh. Chris Spears, Ornet. First of all, I want to say a great presentation. I want to thank Dyn especially for, this is I think your third time talking about automation here at NANOG. Thanks for repeatedly sharing your updates. Now, I think arguably anyone that's tackled this or tried to tackle this will say that importing and bootstrapping all your legacy devices into this, or all that cruft from over the years into this, is the hardest part. And you put up there, you had about 300 devices and 17 different authors. Can I infer that those are engineers?
Mostly, yeah.
Okay. Do you think that that is still, from your viewpoint, still one of the hardest things is getting all those legacy devices in with even staffing levels like that?
Yeah, all those 17 are not in network engineering, so they were in other groups and they don't care about what I'm doing. So retrofitting old legacy configs into this is by far the most difficult part, yes. And it's just a matter of time, and as I said, the one way is to, okay, let's redesign this thing and focus on the new, and hope that the old goes away. But yeah, thanks.
Hi, Steve Feldman, CBS Interactive. I got 2 questions for you. The first one is philosophical. How hard and fast are you going to be able to stick to your manual review for everything process? The particular case I'm thinking of is server provisioning, where you have to flip the port, lag on and off, whatever, while the server is being installed. And right now your process means you have to wait for a network engineer to wake up and push the change. Are you going to be able to stick with that, or are you still going to be able?
Probably not. I mean, that's the way things are right now, and it's an improvement to how they were months ago. But I envision there's much better things that we can do. Use of database, maybe not use the whole approval process and automate some of that, because it's a very discrete operation that you've already done a million times, and you know it doesn't usually break. So yeah, there are more things we can do, and that's a good point.
Okay. And the other question is, are you planning to make any of this available?
You know, I wrote a little demo for the last talk, and I haven't updated it with some of the new things, but I will. I was thinking before giving the talk, I should update it and show some of the things that we're doing with dynamic inventory, and also write down some of the things that we learned that I didn't mention here about using templates, and there are some tricks, you know, indentation and other things that we learned on the way that I will include in there.
Okay, thanks.
Hi, Brandon Bennett with Facebook. Have you looked at using OpenConfig at all, or I guess the next version of this being more vendor neutral?
No, not yet. I mean, I haven't had to, because we're sticking with the same vendor that, you know, in a way makes your life easier. If we start diversifying, then of course we'll start looking at more vendor neutral things. I mean, ideally every vendor will support netconf at some point, and if it's not netconf, then it's something else. But as long as a vendor provides me with an API, I'm happy. So with these tools, you can have the same data and different operations. You know, the basic information that you need to pass a device is very similar. You know, what changes is what API are you using and what format you need to pass. So hopefully that will be an addition and not, you know, throwing away what we did and redoing it again.
Sure. Thanks.
Well, thank you all so much.